In this question, we're told in engineering, a crank and slider mechanism can be used to change circular motion into motion back and forth in a straight line. So as our slider move in and out, the connecting rod then, so this point here, is going to move in a circular motion around like this. Now, in the question, we're told that in the diagrams below, the crank OD rotates about the fixed point O. The point C slides back and forth in a horizontal line. CD is the rod that connects C to the crank. The diagrams below show 3 possible positions for C and D, with OD equal to 10. So there's our radius, which is 10. And DC then is 30 centimeters. So as CD rotates, it's still going to be 30 centimeters all throughout that rotation. Part A then in this question, the diagram below shows a particular position of the mechanism with angle DCO equals 15 degrees, and we need to find angle COD corrected nearest degree. So I'm just going to label the angle COD as theta. Now, I have matching pairs of sides and angles, and if you have matching pairs of sides and angles, then we can use the sine rule. So A over sine A equals B over sine B. Now I'm finding an angle. So if you're finding an angle, I'm going to turn the formula upside down. So sine A over A equals sine B over B. And it's theta we're finding, and opposite that is 30. So I have sine theta over 30 equals then sine 15 over 10, as they are matching. So now sine theta will be, I'm going to bring up to 30 and multiply, so 30 times sine 15 over 10. So now theta is equal to the inverse of sine of 30 sine 15 over 10. Putting all this into the calculator now gets us 50.9, and it's corrected nearest degree, so that means theta equals 51 degrees. Okay, part B then, we're told as D moves in a circular around O, the angle alpha in the diagram below increases. The distance CX then can be considered to be a function of alpha written as f of alpha. And we need to write down the period and range of f. Now, before doing this, I'm actually going to do the table question first. So we need to complete this table, and we need to complete the table below for f of alpha. And now remember that f of alpha is the distance of CX. So I write that here as well. So the distance CX. And we can see there, so at the start in the first position, it's going to be 30. So that means when alpha is just here in a straight line, like that at 0 degrees, C and X is going to be 30. Now, when point D moves up here to 90 degrees, point C is moved in, so it'll form a right angled triangle. So I'm going to go up here to the top and draw the same right angled triangle. So I have 90 degrees, my radius is 10, and let me just write in the points as well. So C, my origin, and I have point D. And I know that the length of CD is 30, as that is given in the original question, because that length of CD is going to remain constant for all of this question. So now I can find out what CO is and use Pythagoras. So I'm finding a shorter side, so it'll be the square root of 30 squared minus 10 squared. and that is equal to 20 root 2. Now, this is the distance from C to O, but I want the distance from C to X. And so if C is here, O is here, and it's from X we want to find, the radius is 10. So then to find Cx, we'll have 20 root 2 minus 10, and that will be equal to 18.28, correct 2 decimal places. So fill that in here, 18.28. Now, the next one we need to find is Cx when the angle is 180 degrees. So for our point C is here, and if the angle is 180 degrees, D is here, X will be here, and here we have the circle. Now the radius of the circle is 10, so that means the diameter is 20, and from C to D is 30, so that means that this has to be 10. Because again, from C to D is 30, I'm taking 20 away as my diameter, so Cx is going to be 10 centimeters. Now for 270 degrees, so which will look like this in green, so 270 going all the way here. Now I can see that this triangle in green is the exact same as the one in red, so it's just pointing down rather than pointing up. So that means that my value for Cx is going to be the exact same. So my value for Cx in this one is going to be 18.28 again. And then finally then 360 degrees. So that's going to be a full rotation, so back to the start. So the exact same as 0. So that's going to be 30 centimeters. So now with the table filled in, the period and range is very easy. So the period is when it repeats. So I can see that this repeats after 360 degrees. Then the range, your smallest to the biggest. So our smallest value here is 10, and our biggest value is 30. And that's that part of the question done. Now the next part of the question, we need to use the values from the table to draw a rough sketch of f in the domain from 0 degrees to 360 degrees. And then draw our graph on this grid. So you can see the first thing here, I've drawn an axis with my degrees at the bottom, and then on the left then is the f of alpha. So the first point there is 0 degrees and 30. So I'll just write in 0 as well. So 0 and 30 is up here. 90 and 18.28 here. Then 180 and 10 here. Then 270 and 18.28 again here. Then 360 and 30 up here. So let's join up these points now. And there's our graph. Okay, next question then. Referring to diagrams 1, 2 and 3 near the start of the question, for which of the 3 positions of the mechanism will 1 degree change in alpha cause the greatest change in the position of C? Explain your answer. So now you can see I've brought the diagram here from the start of the question. So the angle here of alpha, so when that changes 1 degree, which one will create the greatest position change of C? So now I can see that the first one we have there, so that's just going to be 0 degrees because it's a straight line. Now for our diagrams 2 and 3, I'm going to use a protractor, and this one will be 60 degrees, and the next one then is going to be 210 degrees. Okay, so now that I have my degrees, I need to go back to my graph now and see how I can use these. So here's the graph that I've drawn, and we need the values of 0 degrees, which we have, but we also need 60 degrees and 210 degrees. So 60 degrees will be here, 210 will be here. And I already have the 0 as well here. So I can see there, so 0 degrees here, that slope is completely flat. That's just a slope of 1. So 1 degree change here, okay, it won't make massive difference. 60 degrees then, 60 degrees will hit the graph here. So you can see the tangent here is very steep. Okay, so at this point here, okay, we're looking at a very steep slope. So 1 degree there would make a big enough difference. The next one then is 210. And at 210 as well. So again, it's pretty steep there, but not as steep as the 60 degrees. So our 60 degrees then, we can see is the steep. And 60 degrees then was diagram 2. So our answer then is diagram 2. And their explanation then is the slope at 60 degrees, diagram 2, of the graph is steeper than in diagrams 1 and 2. The last part of the question then, the diagram below shows another crank and slider mechanism with different dimensions. In the diagram, AB is 36 centimeters, AX is 31 centimeters, and the angle BAO is 10 degrees. And we need to find R, the length of the crank. And we need to give the answer in centimeters, correct to the nearest centimeter. Okay, so I don't know what R is, so I'm going to write in the other radius here as well. Okay, so from here, I need to use the cosine rule. So the cosine rule, so A squared equals B squared plus C squared minus 2BC cos A. Okay, so I'm going to call this side A, this side B, and this side C. So that means we have R squared is equal to 36 squared plus now 31 plus R all squared minus 2 times 36 times 31 plus R times the cos then of 10. Okay, so let's start working this out. So R squared now will be equal to 1296, so expanding the brackets then, 11961 plus 62R plus R squared. Then minus 2 times 36 is minus 72, and minus 72 times 31 is minus 2232. Minus 2 times 36 minus 72 times R then is minus 72R. And all of this then is times by cos A. So I'm going to separate this bracket here and cos 10. Okay, so I want to just tidy this up a bit here by expanding the bracket. So expanding that, I'll have minus 232 cos 10, then minus 72R cos 10. And then I can simplify some values here. So 1296 plus 961. And that is 2257. I still have plus 62R. Then I can see I have an R squared here as well. So an R squared on both sides of the equal sign. That'll cancel out because if I bring one across, one will be minus. So now what I'm going to do, I'm going to bring all the R's to one side and all the numbers to the other side. So 0 equals to this. So I'm going to bring over anything that has an R. So the minus 72R cos 10 and the 62R. So bringing those across, I'll have 72R cos 10 minus 62R equals now 2,257 minus 2,232 cos 10. Now in the left then, I can factorize out r. So I'll have r then 72 cos 10 minus 62 is equal then to 2,257 minus 2,232 cos 10. So an r then is equal to 2,257 minus 2,232 cos 10, all divided now by 72 cos 10 minus 62. Now putting all that into the calculator gives us 6.6144, and we're asked to correct it near a centimeter, so that means r is equal to 7 centimeters. And there's our answer.